All right. So, keep going. Mass. In the lab, we will measure mass in terms of grams. Okay? 1 kilogram is much bigger than a pound. Okay? A kilogram is 2.2 pounds. Who wants to switch to metric system because of this? I would love if we switched to metric system. My weight would go way down, right? There's 2.2 pounds in a kilogram. I'm not going to tell you exactly what I weigh because it's a lot. But it would go down by over half, wouldn't it? I'm just trying to get in our way. Water freezes at 32 degrees Fahrenheit with temperatures that boil.
100.
212 Fahrenheit. How useful is that? Not very, huh? The Celsius scale is based on that. The Celsius scale is based on the fact that water boils at 100 Celsius and freezes at 0 Celsius. The Fahrenheit scale was originally based upon body temperature. 100 Fahrenheit was supposed to be body temperature. They weren't very good at measuring, okay? Today we know it's not exactly 100, but we still keep that scale.
Is that supposed to be a C?
This one right here is.
Yeah.
Yep. It can't freeze at both, can it?
Mm-hmm.
Yeah, that's supposed to be degrees C. Yep. Now, the third temperature scale is Kelvin, and we'll talk about that more when we get there. It's an absolute scale. It goes down to 0. 0 Kelvin is the lowest temperature you can get. Time is seconds, and we said it's elapsed time. How long did it take for something to happen, right? Like it took way too many seconds for that computer to reboot, didn't it? Exactly. Okay, that's what we're talking about, not what time of day. Okay, I don't really care if you know the difference between SI and metric units. It's in your book, I don't really care. What I would care about is what units would we use to measure volume normally? What units we use? Liters or milliliters, okay? I don't really care if you know the difference between SI. The SI unit for volume is, if anybody remembers, cubic meters, right? Okay. Mass, what do we measure mass in the lab? We measure mass in grams. Ooh. Grams, right? This would be liters or milliliters, grams or kilograms, right? Length, we're going to measure in centimeters or meters. And temperature, we're normally going to measure in
Celsius.
degrees C, Celsius. The SI unit is Kelvin, okay?
So it doesn't have a degree symbol next to it.
Kelvin does not have a degree symbol next to it. Nope. Now, this is what you're going to do in the lab this week, okay? Is make measurements. We're going to talk about how to make appropriate measurements, how to make measurements correctly. This ruler has markings for 1 centimeter, right? Look at that piece of wood right there. I guess that's supposed to be wood. What would you say the length of that piece of wood is? 4.5. There's no markings for 0.5 on there.
I know.
Why are you putting a 0.5 in
Because
there?
that's the kind of ruler I have.
You're allowed to. Why? Because you get to estimate in between the two. You know it's more than 4 and less than 5, so you can estimate. Do what? 4.5, 4.5. I don't like fractions. 4.5 decimals. Okay? Because the metric system is all decimals, not fractions. It's all decimals. There's no thirds or anything. We get to estimate in between. Now watch this. What if it had markings like that? So originally we said it was 4.5 centimeters. Now what is it? It's not 4.5 anymore. It is now 4.50 centimeters. Why is that? What's changed? The markings on my measuring device have changed. Okay? My markings are now better than they were before, aren't they? It is a more precise measuring device. Here's the rule when you make measurements in a lab. You record every digit that you're absolutely certain of plus one estimated digit. Okay? So every digit that it has a marking for, that ruler now has markings for 1/10 of a centimeter. Everybody agree with that? So because it has markings for 1/10, I can estimate 1/100th of a centimeter. Okay? If it only had markings for 1 centimeter, then I estimated to 1/10 of a centimeter. That was my first number up here, 4.5. Now when I add the markings for 1/10, I can go to 4.50. Now, depending upon how it's measured, tells me which one of these I'm able to use. What kind of markings does it have, okay? And all these digits when we get there are significant because I was either absolutely certain or I made a very good estimate of it. Okay? Fair enough? Measured numbers are always obtained by using some sort of measuring device, and they can measure things like length, mass, temperature, okay? And there's the rules. All the marked lines plus one more estimated digit, okay? So, here we have 3 different pieces of wood. This first one up here is just like the one we had originally, right? What is this ruler marked in? What place is it marked in? Is it marked into hundreds, tens, ones, tenths, hundreds? It's marked into ones place, right? So I report to the ones plus one more digit, so what do I report to? To the tenths place. Now this ruler is marked in what place? This is marked to the tenths place, isn't it? So I can report to the hundredths. Look at this ruler down here. It's once again only marked to the ones, so I report to the tenths place. In this case, it looks like it falls right on 3, doesn't it? But you still report to the tenths place, 3.0. Now what if it would have had markings? Let's say these are tenths. Okay? Now what would it be? 3.00, exactly. Because it falls right on that 3, but it has markings for the tenths. I still have to report it to the hundredths. Okay? Students often forget, but Dr. Powell, it's right on 3, so it's 3.0. No, it has markings for 3.0. You got to go one more beyond that. Okay?
So now, on the example number A at the top,
Yep.
that one is listed as going to the tenths, but would it be wrong if you extended it to the hundredths?
Yes, it would be. Because once you go beyond this digit right here, it now becomes a wag. And wags are not good.
So you just have to add a 0 to the end? The first one?
No, the first one's right like this. It's 4.5.
No, so if it had the marks.
If it had the markings and you thought it was right on 4.5, you would add a 0 then, yes. A wag is just a wild ass guess, and we don't do those. Okay? Because we're already estimating this digit, right? There's error in that digit. Why would I go down even further? Once I get beyond that 5, then I'm gonna tell them what that is. Beyond that, right? That's just total guess then. This is not a guess. There's a difference between a guess and an estimate. Okay? This is an estimate, but it's a good estimate. I might say it's 4.4. Is that okay? Yeah.
Yes.
You might say it's 4.6. That's okay too, because there's error in this last number where we estimate. Okay? That is where, in this number, the error is here, right? It's in the 5, the second 5. That first 5, we're certain of that. It's only in that last digit where we're estimating that there will be differences, or should be differences, can be differences. Okay?